Hello everyone, welcome back to the channel. Today we are going to solve this question on the code forces called A Tale of Two Lands. So the question states that some king uh, some king chose two integers x and y, and he gained the control over the land from mod x to mod y, including mod x and mod y, and then another king came and which took control over the region of mod of x minus y to mod of x plus y, including both mod of x minus y and mod of x plus y. So such that the second king's territory includes means the includes the territory of the first king, means first king's territory should lie between the endpoints of the territory of the second king. So that's the thing. And now Jose is stuck on a question of his history exam. What are the values of x and y? Jose doesn't know the answer, but he believes he narrowed the possible answers down to n integers. Now he wants to know the number of unordered pairs formed by two different elements from these n integers, such that the legend could be true if x and y were equal to these values. So okay, that's the question. Let us take a look at this sample test case. 3, 2, 5 and minus 3. 2, 5 and minus 3. So if I make this pair 2 and 5, the first king will have control over mod of 2, which is 2, and mod of 5, which is 5, and second king will have control over mod of 5 minus 3, which is 2, and 5 plus 2 is 7. So clearly this territory is not included in this one. Okay, so this pair isn't good. Next, 2 comma minus 3. So for this, first king will place the endpoints of his territory on 2 comma 3, because mod of minus 3 is 3, and second king will place the endpoints of his territory on minus 3 minus 2, mod of minus 3 minus 2 5, and mod of minus 3 plus 2 1. So clearly this region is mentioned in this region 1 to 5. Okay, so this pair holds. So we have got one unordered pair. Now what about 5 comma minus 3? For 5 comma minus 3, first king capitalizes the land which is from 3 comma 5, and the second king capitalizes the land from the 2 comma 8. So clearly this first region completely lies in the second region. So yes, 5 comma minus 3 is also a valid pair. So that's why two unordered pairs are possible for this test case. So indeed that answer is true. For the second test case, 3 comma 6, we have to check only one pair. So we are checking on this left side, 3 comma 6. First king will capitalize from 3 to 6, second king will be quick to capitalize on 3 to 9, which is, so this region completely includes this region. So yes, the answer should be 1, and indeed it is, answer is 1. So this way we have to count the unordered pairs of this x comma y, so such that given condition holds, this condition holds. So what we are going to do is that we'll make a quick observation. So writing it down mathematically would be something like this: minimum of mod of x minus y comma mod of x plus y should be less than or equal to mod x comma mod y, which in turn is less than or equal to max of mod of x minus y comma mod of x plus y. Now if I put x as minus x here, so it will become minimum of mod of x minus y. See, this won't change, because if we put minus x here, it will become mod of x plus y. If we put minus x here, it will become mod of x minus y. These two will remain the same. Mod of minus x is mod of x, then less than or equal to, here the same thing. The arguments change in the same way. Max function or mean function isn't really affected. So inequality remains same. Inequality basically remains the same. So now, without loss of generality, I will make xi and yi's as positive, because see why will I make them positive is that, see, if the pair 2 comma 3 works, if the pair 2 comma 3 works, then by this argument remains this inequality being remaining the same, minus 2 comma 3 should also work, right? Same, if I alter y also, then the inequality will also remain same. So if it works for this one, then it should also work for 2 comma minus 3 as well. So if this pair works, these three pairs will also work. So that's why, to just simplify the case, I am converting all of them to positive, their positive counterparts. So then inequality converts to simplify the inequality also, yeah. So minimum of these things will be mod of x minus y, as you already know that mod of x plus y is gonna be positive, and this mod of x minus y will be less than mod of x plus y, as both x and y are positives, which will be less than or equal to x comma y. Mods open with the positive value because all the values of x and y are rendered positive in this step. So less than or equal to this, max of these two will be x plus y. No need of mod because they both are positive. So see, this second inequality always holds. Second inequality always holds. So we are left with mod of x minus y less than or equal to x, and mod of x minus y should be less than or equal to y. So from here, opening mod with the its positive value means assuming x is greater than y, then it will become x minus y is less than or equal to x, which is always true. And opening it with its negative value, it will get minus x plus y is less than or equal to x, which converts to y is less than or equal to 2x. This is our final inequality. We'll mark it as 1. Then solving the second test case, solving the second scenario, we'll get, see this thing, if we open it with minus sign, which will be always true. If we open it with the plus positive sign, so it will be mod of x minus y less than or equal to y, so we get x is less than or equal to 2y. So this is our second inequality. So what I can do is that I will sort the vector or the array they have given and assume that x is less than y, less than or equal to y. I'll assume it. So I'll keep two pointers where pointer of y will be always in the right place, in the towards the right of the pointer which has x. So this condition will always hold true. Yes, we are narrowing down our inequalities. So this will always hold. Now we only need to check for this thing. Yes, this thing. So how we can check that? It is easy because of the two pointers method. So let's head to the code. So this is the code. Here output is input is completed. Here only, if the v of I is less than 0, I'm rendering it to the positive, then sorting, initializing these variables. Now while left is not equal to n and right is less than n, and this condition, we saw that this condition is there for this inequality. And basically, if this holds, we are incrementing right plus plus, and all the pairs will be counted as the good pairs. So answer plus is equal to right minus left minus 1. The pairs which are between that left and the right, if we will keep on increasing x, fixing the y, and those pairs x and y will always be the good pairs. So finally incrementing left as well till we not get left not equal to n, and finally outputting the answer. So that was it. Hope you enjoyed the video and the solution as well. uh, Thank you for watching the video. Stay tuned, like the video, subscribe the channel. Yeah, see you again.